Yeah, thank you. So yesterday we have left one question like regarding the Snowflake schema, star, Snowflake, galaxy, the differences I have said and characteristics also I have said. And one more thing that you have asked, like some facts, what can be done, like the outputs. The first question is like whatever the dimensions are there, they are related to descriptive data that I mentioned already. One second. Something is wrong. Sorry, give me a little time. Yeah. So I kept slate in reverse direction so that top become bottom and bottom become top. Okay, fine. Now, see, I told you even in star schema, stack is something like centrally located. Dimensions will be there like this. See, I told you all the descriptive data will be stored in dimensions. In the facts, only numerics will be stored. It means like final outcome, like. So from the facts, you can do analysis easily. I give you an example. Let us say there are different branches of the bank, and head branch like is connected with this fact. I want to know what is the lien amount from all the loans from all the branches. It means in D1 also, in dimension 1, there are some loan accounts. There in D2, there are some loan accounts. D3, D4, there are different dimensions are there. In each dimension, there are loan accounts. Let us say here 10 loan accounts are there. Here 20 loan accounts are there. Here 10 loan accounts are there. Here 10 loan accounts are there. It means total 50 loan accounts are there. Now each dimension will have that loanee name, how much he has taken, how much interest, all the calculations can be calculated here in dimension 1. All other descriptive data, what are the documents they have provided, who are all get signed in that document, all this data will be there in D1, D2, D3, D4 accordingly. But coming to fact, when you ask something like what is the lien amount in a particular month, when a query comes to the fact, then from the fact the value can be given. It means the total value of that lien amount can be stored here. That's why aggregated values are stored in facts. So from the facts directly it will go to reports or dashboards or graphical analysis. That is the first question. I think Vijay you asked that. I think maybe Murali you asked that. So the next question, like, I think it is clear right now. Yeah, thank you. So coming to Snowflake schema, I will show you the diagram from Greek's site. Please. You can see actually this site, which is little, very interactive. See, I hope you can see this figure. So when I mention star schema, see, dimensions are at the end of the star, at the edges of the starlight. It means only one dimension will have in each, what you call edge, and they are connected to the centrally located fact. But in this case, you see, the sales is the fact, like in this, product ID, order ID, customer ID, employee ID, total, quantity, discount. It means these are values can be stored, and by using these values, you can do some analysis or queries can be answered. But here, not only see, here in the star case, one dimension will be connected to this. Let us say the sales will be connected to customer dimension. But again, this customer dimension is connected to city dimension also here. In this case also, you see, sales is connected to employee dimension and connected to department dimension also. Okay. So they are connected to another attributes like. That's why I said I told you here it is like lookup tables will be more in the case of Snowflake schema. In the case of Galaxy schema, like this Snowflake schemas are available many. It means it will be more and more complex like that. In the first case, see, even in the customer dimension, customer ID is there. Customer ID is there in sales. Now, this city dimension also will have in relation with customer dimension. It means mutually linked they are. It means one attribute depends on one entity depends on another entity. One table depends on another table. Like that, many dependencies will be there. But in the case of star schema, that dependencies are less. That is the only difference. As I said earlier, the around centrally located fact, there are many dimensions. From the dimensions, it will collect the data. Who facts will collect the data. From the facts, you can go for reports. That is what actually Snowflake schema. In the constellation schema, you can imagine that figure I told you satellites like. It means many, many Snowflake schemas are available in the last schema like that is that we have seen. It means it is combination of that. It means complexity will be more. That is what actually Galaxy and constellation schema. Clear? That is Mr. Vijay.
Okay, sir.
Yeah, thank you.
Snowfall.
Yeah.
Second one is the best option, sir.
Snowflake.
Data storing.
ET. Someone is speaking, I think.
Snowfall.
Yeah, Snowflake schema
is the best option for data storing.
I told you already. It is depends on the requirement only. Requirement of the business. It is. I told you even in the beginning, whatever the business requirements are there. Actually, that is the major in ETL testing also will come like functional requirement specifications and business requirement specifications. It means what is the business people or the client asked you. Based on that only we go for schema. Because the outcome is same, but it all depends on the time it is taking, the memory it is taking, the cost it is taking. Like these are the factors we consider. But generally, as complexity will be more as we think, there is much accurate values can be we can get. It means all time the last schema what we have read that is only good, but all the time we don't go that. See, suppose a man who is from village want to use mobile, he don't want actually Apple phone is good, the all time better, but for that candidate Apple phone is not at all suitable. It is like based on the requirement only. Okay. So after this we go for SCDs, slowly changing dimensions. Already we have seen some sort of dimensions already in the last class. Now in that slowly changing dimensions also is one of the part. This we need to understand. Just these are the concepts, like very simple. SCDs, slowly, the name itself, slowly changing dimensions. What does it mean? Actually, dimension we know, we have seen already in all these three schemas we have so far covered. In that there are many dimensions are there. In that dimensions, see the data like crude operations will be there in SQL like you heard. You can create, you can retrieve, or you can update, you can delete. Few things will be there. Even in dimensions that are because it is transactional data. It means you have to change the value. For suppose in a particular dimension, one account as we have seen that example, the amount, let us say 10 lakhs, let's say principal amount. Suddenly the guy came and he asked some more amount he wants to borrow. It means this 10,000 should be changed. Let us say another 10,000 he asked. It means the new value is 10,000. Now new value is not 10,000, the added value is 10,000. Already the value existed is 10,000. It means the total value should become 20,000. Or sometimes this 10,000 I should replace with 20,000. That also I can say. See, two ways I can represent this issue or task. I can add 10,000 because he borrowed one more 10,000 extra, or I can replace the 10,000 as to 20,000. That also true. In the two cases, finally I want to replace the 10,000 with 20,000. It means in dimensions generally we change the data. So in that case, it is slowly changing dimensions. Like it means the attributes or the values in the dimension we are going to change. Based on that, we have three types of SCDs. SCD type 1, type 2 SCD, type 3 SCD like. So what SCD means? It stores and manages both current and historical data. It means already history of data is available, like let us say 10,000, because this 10,000 is the history of data because it is already accumulated over 10 years. After 10 years, he wants to take one more 10,000 extra. It means the value should become 20,000. So it has to store the 10,000 and it has to manage also. What it should manage the dimension. If you take another 10,000, that 10,000 also should be added. Added means updated here, because actually adding may be additive, that is different. So we have to update with 20,000. That can be done in dimensions. That is called slowly changing dimension. It is actually a critical task. Generally in ETL we say that SCDs are critical tasks. Why? Because see, if you change one dimension, it is not just a dimension, because this dimension is also linked with fact. It means when here it is updated, when update comes in the dimension, the same update should go to the fact also, as it is related, as it is interrelated. So this is critical task. So suppose if the 10,000 become 20,000, when you go for analysis or when query comes like, how much the loan you should pay, the answer will be wrong. In that case, based on 10,000, if it is calculates, then automatically his value become less and that people will lose money. So very critical task it is. SCDs are, it plays most critical task role in ETL. So SCDs are important. So here I told you three types of categories: type 1 SCD, type 2 SCD, type 3 SCD. So what in type 1, what happens like? See, new data, as I mentioned earlier, 20,000 is the new data. Actually, see, 10,000 plus 10,000, it is like 20,000 is the new data. So overwrites the existing data. You want to overwrite the existing data 10,000 with 20,000. So in that case, we generally go for type 1 category like. Okay. In this case, generally existing data will be lost. It means that 20,000 will not be there, and this 10,000 will not be stored anywhere. After replacing with this 20,000, it means once if you update with 20,000 or overwrites with 20,000 value, the 10,000 value will not, you cannot see anywhere in the schema. Actually, generally you can think like, why can't we retrieve the 10,000 also? You can retrieve, but in this type 1 category, we generally not able to retrieve the 10,000 principal amount that is already replaced with 20,000. It means the most current value. It means the new value. The new value will be available. Old value will not be available in this type 1 category. Maybe sometimes we need such type of things. So in that case, we go for type 1. It means current value will be there. Current value only can be seen. Old value cannot be seen. That is the type 1. Type 2. Actually creating another dimension record. It means already old dimension will be there and we create new dimension also. In this, what we do? In this overwrite we do. It means we don't keep old records. It means historical records we don't keep. In this case, we create new dimension. The name itself it is there. It means old dimension value also will be there and new dimension value also will be there. Create new dimension. It means in this case, you will have 10,000 also you will have, and 20,000 new replaced value also will be there. Okay. It means it can retrieve the full history of that value. Full history you can retrieve, right? Many times it will change. Every time as you change, it will create a new dimension. So which is good actually, because I can understand what is the original amount first he took, and after that what are the things and add-ons are happened, or what are the records have been changed. Okay, so in this type 2, that is the advantage. Like, so type 3, in this current, we create a current value field. It means what? Create a current value field, almost similar to type 2 category only. So what actually here? See, in this case, it stores 2 versions of values. Like, it means first version means old version, that nothing but historical version values it will be stored, and it will store the new version values also. But remember, but for selected attributes only. The difference between type 2 and type 3 almost similar. It also creates new dimension, and it stores the new values. In type 3, it also creates a current value. It means old value also will be there, historical value also will be there, and it also like it looks like creating new dimension. But we don't want for all the attributes, because there are some important attributes will be there, there are some unimportant attributes will be there. Only for important attributes it will create. That criteria or that case will come under type 3 category, slowly changing dimension. This is what actually slowly changing dimensions we use, and we say that it is a critical task in ETL. And from this also there are some interview questions are available every time. They will ask this. You can understand from the name itself, slowly changing dimension. It means when the change comes slowly in dimensional attributes, that dimensional attributes change, how we are representing. That is categorized as 3 categories. Type 1, overwrite. Type 2, create a new dimension. Type 3, create a current value field, but for a selected value. For a selected values. That is the difference we have to say. For a selected values, no, for a selected values or attributes. Clear SCDs? Any doubt you have?
AMMAJI, you were saying new dimension will create, or it will create this new record in the same dimension.
In type 2, it creates new dimension.
Type 2. So
in type 2, yeah.
The initial value 10,000, that is dimension 2. Let's say.
Yeah.
Okay. Next one more record will come. That means that will create as new dimension. Is it 20,000?
Yeah.
Okay.
It
And
is
that
like
new dimension.
Yeah, actually new dimension will be created, and that also, see, it is time bounded. Generally, see, we think like, right? See, when old dimension also there, nothing but old record is available. But how long time you keep that? Generally, a person is there, Loney is there. Loney, how many years? Generally, 10 years will be there, right? Suddenly, yeah.
Let's assume dimensions is nothing but is we can assume it as stable, or it is just fixed storage data or something like that.
Actually, it is fixed, but for a particular time. That's why generally, actually, in this, each and every record have some effective time and some expiration time. It means for every record I keep expiration time. It means after that time it will be closed. The old record will be closed and new record only will be available. That is type 2 category.
So that means it is stable, just a simple storage of some.
Yeah, dynamic storage only. It is not fixed. It is dynamic only.
Facts only with this, you can assume it as stable. It will be always same.
Actually, your voice is little getting break. Yeah. So half of what?
So here, now it is fine.
Yeah, now it is clear.
Yeah. So let us say facts only have it is, we can assume it as stable. So remaining everything will be temporary storage. It will keep on changing.
Of course. Okay. Dimensions are all time volatile. That's why we have seen already. Volatile, non-volatile is the fundamental characteristics I mentioned even from the beginning onwards. DWH characteristics I mentioned, volatile, non-volatile. Here also, dimensions are volatile.
But it were non-volatile means
changing.
It will change, not delete. I thought it will not delete. It will be available. Okay.
available, but for a fixed time, like that time we decide. We keep, right? Sometimes you now you see actually this is the dimension. A simple example I can tell you. Now that Microsoft people have given one option like whatever the data you can store in on desktop, that will be there for 30 days. Even you can remove from desktop, but it will be stored in cloud. I mean like drive, Microsoft Drive. It is like that. It means up to 30 days it is valuable only. It means new records will be created and it will store. After 30 days again, you see every day you remove some data, right? Accumulation will come like that. So for every 30 days it will clear itself. It is like that. So for a fixed time it is available. After that it will be, we lose that data or that record. Clear?
Okay. Yeah.
Yeah.
Sir,
Yeah. Vijay?
three types of SDs ఉన్నాయి కదా సార్.
Yeah.
స్టోరింగ్ విషయంలో హలో
Yeah. Tell me, Vijay. I can hear.
స్టోరింగ్ విషయంలో డైమెన్షన్స్ మీరు ఏది చెప్పారు కదా సార్ ఇప్పుడు
Microsoft
స్టోరింగ్
example.
విషయంలో అది కాదు, డిమాండ్ ఏదో చెప్పారు కదా సార్ ఇప్పుడు
Dimension.
స్టోరింగ్ విషయంలో ఏది చేయండి. స్టోరింగ్ విషయం
Storing. I mean, which one you are talking about? Type 2 or type 3 or exactly what?
టైప్ 2 సార్.
Type 2. See, in type 2, old data is there, let us say. Some old data is there. Now, historical data, you want to change. You want to change the data. So what I do, I create a new dimension and I will save that new data. It means old data is available, but in the type 1, old data is not available because you are overwriting it. But here I am not overwriting it. I keep the old record as it is and I keep new record also. But how long time I keep my old record? I will fix the time of expiration. It means I will kill that after some time. Maybe it is 3 months or 4 months or 6 months like that. But I keep.
It's called simple data, sir. Simple data and called.
It is
Simple
old
storing
data. Old data. Whether it is
స్టోరింగ్
simple.
విషయంలో దాన్ని సింపుల్ స్టోరింగ్ అని పిలాలా? దాన్ని స్టోర్ అవుతుంది కదా సార్ డేటా కొంత టైం వరకే, దాన్ని సింపుల్ స్టోరింగ్ అనాలా లేకపోతే వేరే ఏదైనా వర్డ్ ఉందా?
Actually that no data, it is like old data, simply that's all. Here old data or new data will come, like old data is replaced with new data. So that old data or historical data will be removed after some time. That is what actually expiration time I mentioned.
Okay.
But you can say dynamic, like I maybe I think.
Oh yes sir, this
dynamic means like changing. Yeah, dynamic means changing, like see, already the name itself is there, like slowly changing dimensions. It means
ఇది మూడాట్లకి అప్లై అవుతుంది సార్, 3 types కి.
Of course, here also current value is updated. It means it is changing. Here also current value is updated. Here also changing. In 3 cases, it is a dynamic only. See, when something like static, if you say static and dynamic, see, fact is almost like static. Why? Because in that we don't change anything. All the changes occur in dimensions only. Around the fact, the changes will occur. That changes will be reflected into the fact. But by default, in fact schema, we don't do any changes. Why? Because see, I cannot say like some loni, what is the calculations and all not available in fact, right? Somewhere in one particular branch, it is available. That transactions and all. That guy should update fact. Fact itself cannot update itself, right? So that is what actually I said, dynamic and static. Okay.
Okay, dynamic.
Yeah, dynamic. Thank you. So we go for now manual testing.
Just take this screenshot, no?
Yeah. Anyhow, I think it is available in video. Like we are recording it, right? So anyhow, I have taken screenshot also. I will share you people.
Okay.
So manual testing is also one of the important concept in testing, and even not only in ETL testing, in every testing, like. And these are very, very basic, like everywhere. Even from the beginning, I told you when we design something, when we model something. Maybe I think when dimensional modeling, I said that time I have taken some steps like First we have to take all the requirements from the business, and we have to, logic we have to create, and then we write code, and then we develop a physical model. So these are the basic steps that will be reflected throughout this testing life. Okay, even that different names we call like SDLC, software development life cycle, software testing life cycle, like various names are there. I told you in the even the same thing every time. It is like similar. Most of the cases, almost all the concepts are similar, but we have to understand two things. Even in the beginning, again, I am telling the same thing. It is like what is the sequence you are following, and after that, what is the feedback you are giving. It is like something happened, like let us say task. The task have its own sequence. It means own steps, step by step, and then some reports will come. That report may be right, may be wrong. It means what you have to give. You have to give feedback. Once the feedback again goes to task, again you have to think based on the output. Actually, based on the output, feedback will come. That feedback will go to the task. Again, now here question comes whether you want to repeat this cycle or whether it is successful. If it is successful, no need to repeat. So this is the case happens in all the testing cases, like even in manufacturing, any physical manufacturing or software development, anywhere or testing cycle. These are the steps are common. So the same step now also we see in manual testing, but with different names. That's all. Just names will vary. Now let us see. So what do you call manual testing? See, firstly, test. Test means we want to find quality of a task or a job or a software or a product. That is what generally we call a test. Test means quality, and generally, is it important? Test, generally we think, right, testing is important or not. If something is already made, why we need to test again? See, suppose if the testing gone wrong, the outcome sometimes it is disastrous. It means very, it may be damage to the life, it may be damage to the company, maybe damage, big damage to the industry. Anything may happen. There are some testing, like we have the bike, let us say. Now recently I think you might seen like one electrical bike exploded in where we call it is Tamil Nadu. See, already that bike is tested and they proved quality. They said actually quality is good, so the people bought. Suddenly it gone exploded, and two people died, it seems. Two people have died. Now see, this damage, generally software means in that one, in electrical thing, one electrical what you call control cycle will be there. The control equipment actually costly, hardly it is like 6 or 7,000 in the bike, which costs 70,000 or 80,000, like. But this control will have all the outcomes, like, first suppose some damage is occurred. If red light comes, first suppose they can put it right in the software. Something leakage comes, or battery is slowly expanding. So it means the possible chance of explode can be detected by using that control circuit. But maybe in that case, in Tamil Nadu case, maybe that type of software is not there in that bike, or testing may not be done properly. It means almost two lives. It means it costs, you cannot calculate how much does it cost life, because it is maybe it is software, or it a company, or some product is gone bad, it is okay. But coming to life, so it is very, very important. So such is the software actually. So software you have to test compulsory. So that's why we need to go for test. What we test means quality of that particular product or software or tool or whatever it is, like quality we test. So manual means what? Coming to manual, generally manual means, as man we do, like, see, man means it is not like physical components. As it is already a software component or soft component, we use computers or we use some tools, but still we call manual testing. Why? Because it is not an automated testing. When you say automation, generally you don't give anything. Maybe sometimes manually little operations, maybe switch on, switch off operations, you do that's all. Remaining the whole testing, the device will do itself. Let us say MRI components, I think I have worked that in sort of things like in MRI components also, like, you know, that X-ray machines are will be there. Like, if you do a small mistake in that, that causes a life damage to the life, because when what do you call X-ray falls on the body, it has to distract into all the directions. It means you have to write a software behind the mission or operation in a such a way that the scattered waves should not concentrate in a particular point. If it is concentrated at a particular point, there a hole occurs in the body of that patient. It means that testing behind there is a software, so that much damage generally will occur if testing gone failed. But in this case, we do manually only. That such components we do manually, and few things we do completely automation testing. Nowadays you can see that everything become automated in all industries. And one more thing is like in India, actually already that project has been started. What does it mean? Almost in all public sector units, all central government units, all the manual things become, they are trying to become make it automation. In that case, really there is a much demand will be there in testing in that cases. But maybe I don't know how long time it takes, but sure it will come like in some industries. So manual means a man or physical intervention will be more. It does not mean that there is no automation, like that also some automation will be there, but mostly man intervention will be there most. That is called manual testing. If it is automation, something like manual intervention is very, very, very less. So that is what actually difference between what is testing and what is manual testing, and what is the importance of testing versus automation. So actually it is better, I think, if we stop here and I make it another link as of today only. I think for tomorrow, actually that new platform or something like the platform which stays for 1 hour we keep. But as of now today, we are sorry. I make one more link because already it is given some message to me. So I think it will go. So is it okay, Vijay?
Okay, sir.
Yeah, I make it another link and I will send you in the group, okay? Or should I send to mail also?
Group, sir. Group.
Yeah, group I do then. Thank you. Yeah, it is like manual testing. I told you it is more like theory, but little more and more, new terms, terminology will come in this. So first, we understand what is testing, we check quality and what is the importance of it, and what is the manual testing. In that manual intervention is more, and we say automation, where we rely more upon machines. And what are the skills required in this case there? So what are the skills required in manual testing? Generally we don't do automation, okay? We go for manual testing only. Skills required in this, see what are the manual testing concepts. Generally, what are the concepts that we are using in manual testing, that is important. Skills, manual testing concepts. It means it's like flows, or how the things will be flow like. Functional automation tools also important. Functional automation tools. I told you why again the term comes here. Automation means even though it is manual testing, there are some automation tools will be there. That behind that automation tool, what is the function you are using? That function at least you should understand. Even in the beginning I told you, like, for suppose you do not know what is the box fundamental tool, like in order to test 2 inputs you have to do 2 outputs, you will get it. What is it is like additive function, like. So that function is like, it means what exactly to do. That function means a particular task to be done. a sequence of programming like. It means what is the sequence here? You have to give A, you have to give B, and then you have to compile this box. Then only you will get A plus B. It is like a function. It means a set of things like happen in sequence. So functional automation tools you should understand at least one. There are many functional automation tools are available in the market, but at least one of the functional automation tool you have to understand. And one of the defect reporting tool also you should understand. Defect reporting tool. Why? Because you are working as a tester. You should know this because you have to operate, so you should know this. After operating, when the defect comes, that defect you have to report back, right? That is what we call feedback. After sequence of steps, when you get some output, it may be good or bad, it may be wrong or right, you have to write feedback, right? It means the defects you have to report to the developers or to the technical lead or whatever it is, in that particular group of people who are working on that particular job. So you have to report the defects. You cannot simply report, actually, there is a simple thing I tell you. Very small mistake happened in the, let us say in particular testing. If you say that your leader, the developer, if you say a bug happened, simply you say that a bug happened. You do not tell like, or you can say that it is wrong. See, how can you say that it is wrong? Maybe it is not the business requirement. As a tester, maybe you may think that it is wrong, but sometimes as a developer, that wrong may not be treated as a wrong. Because what developer will do or lead will think that as a requirement of the business or as a requirement of the client, that bug may not be the wrong. It means the way you are reporting the defects are very, very important. It has its own actually, sequence of steps will be there that I will show you later, but this is also important. You should understand one of the defect reporting tool, how to use, and you should understand database knowledge, because you should know how the data is flowing and where the data is storing and what are the operations are doing via that particular database. So this is what you call database knowledge. That is important. And domain knowledge. In a particular domain, you will work, right? In a financial domain, you may work. Maybe you are working on banking. You may be working on insurance. You may be working on payroll session, especially, or any government sector. It means a particular domain, because domain to domain it will vary. Banking transactions may not be as equal to insurance policies, right? Their domain, because their terms will vary, but behind the concept is same. Remember, I told you even in the beginning onward, the concept is everywhere it is same, but the terminology will vary. Some similarities will be there. The similarities we have to differentiate. When you think both are same, then there is no difference. When you understand similarity, it means the little differences between the things, then you can understand the two domains also very easily. So in order to understand more and more domains, you have to relate the similarity between the two domains. Okay, so domain knowledge. These are the fundamental knowledge, concepts that are required to do manual testing. So finally, testing means, the bugs should be removed. It means errors should be removed after testing. That is what we call generally testing. It means finally we are checking quality by validating defect. So when actually, whether it is easy or complex, fundamentally there is a thing like, right? Suppose if someone ask me like, what is testing? Is it easy or is it difficult? I can say very simply whether it is easy or whether it is difficult. I can say simply any word. But when I say difficult, when he asks like why it is difficult, then I have to explain more. When I say easy, the person may ask like how it is easy. In that case, also I have to explain why it is easy. So generally, it is again depends. I cannot say that it is easy or I cannot say that it is difficult. It is all depends upon client requirements. For suppose the client came to you and asked something like to do. In that case, if you understand the requirements from the client very clearly, it means you have to write. For suppose one banking person came to us and he asked to do to test a particular software already developed. See, in that case, firstly I have to know what is the data, what is the database they are using, what is the tool they are using, and how they designed. I should understand all the requirements from that person, and I should understand all the requirements from the POS people and from the developer side. All the knowledge means from the end to end, I should have all the knowledge in order to say that whether I work on it or not. I cannot simply give like someone came like do test means I cannot test it. I have to think all these things. It means finally, if you understand client requirements very clearly, then the testing will be easy. Suppose where the gap in the requirements of the client, then automatically it will become difficult. So fundamentally, that's why even in a software development cycle, one second, yeah, in SDLC we call. So in that also we get these things like, I mean, two requirements we majorly concentrate. That is called business requirement specifications and functional requirement specifications. So these are very, very important things in the beginning. So testing methods I already mentioned, like manual automation. Now we see SDLC. I take screenshot also. SDLC, STLC, these are two concepts will come here. So first we go for SDLC. Software development life cycle. Cycle means which is closed, right? Generally it is closed, like cycle means it's like 360 degrees circle like. It means in order to development something like, you have to follow a sequence of steps in a cyclic manner. That's why it is called software development life cycle. So see what software generally, that a set of instructions so sorry, there it is. So what is software? We know that there are many set of instructions will be there to do a particular task or job, like that is what we call generally software, right? So in the, oh my god, just give me 1 second. Yeah, sorry. Okay. So that is software like definition, and that is what we call software development type cycle. Means it has to a cyclic manner, set of things we do. So in that again, the software is generally like two types. Coming to software, it is like system type system software. The second thing is like application software. You know that actually the difference very easy. Like system software means like operating system. On that we develop some works like operating system. We can say like system software. Application software means like, see, when operating system is already done, on that many applications we can run, right? Like we do now. We are doing Zoom we are running as an application in already existed operating system. So that is called operating system, which is behind, which is there, that is called system software. What are all the applications we are running in a particular computer, or many applications, like you can think anything like camera, one application, for what you call WhatsApp application, Zoom application, any browser is an application. It is application software like. So there are the two types like. Again, application software, because we have to work on this type of things. So two types. One is we can say like product based and project based. So application software, you can think like again product based, like Zoom, TeamViewer. You can think like any Facebook. I mean, these applications like product based. When project based, it means little bigger. Just simply, actually, little bigger. That's all. It is like a big sector. Any industrial, any industry, or any banking industry, any commercial industry, or any insurance industry, like that. This is called like project based application. So these are the different types categories will come under software. Under the software again, application based software, product based, and project based. So now, what is SDLC then? See, SDLC is like we develop a software, a product to fulfill the complete requirements of the client within the some specific time and some cost. It means once a client approach you, first you will take a task because he will come with own requirements. He will come with own requirements. Whatever the requirements, actually types will be there. We will see next in after this. After listening all the requirements from the client, I have to develop, right, a software product, or maybe it's a project. I have to make it. I have to make it a product, or I have to make it a software based on the requirements. It is what are the two things like here, specific time, cost. These two things also we will talk about in the beginning. So in order to do this, this is the process will be there, right? After taking requirements, I kept only make it software, but before that, even in that making it software, like there are many steps will come, we will see. So in that, it is like a complete cycle. Still we give product to this fellow. It means, after all I making, if I will give to the client may accept it, or the client may ask some, add-ons, or he may reject it also sometimes. So in that case, testing will come like, right? Before testing, after testing only we will give to the client, right? We will not simply, making it and simply we cannot deliver it. Okay, because the client may not accept it. So this is what we call SDLC, process of developing a particular software or a product or a project to fulfill the complete requirements asked by the client. Okay, and what are the two constraints here? Time and cost. That is what actually SDLC, software develop life cycle. So what are the phases we have to see in this? This is important. It means when in SDLC there are different phases will be there. The first thing is, already we have seen, requirement. I'm not writing fully. Requirement collection. It means you should not miss any requirement that is collected. If it is missed, actually see, if something is requirement is missed in the beginning, that error will carry on till the product end. Actually, even if you do mistake in between while testing or while making, it is okay. Maybe it is, what do you call, to retrieve it, to modify it, it is easy little. But when requirement itself is missed, then automatically the error will be carried out throughout the product. So here it should be we should be very cautious. So that is called requirement collection. In this, after that, requirement analysis. It means after collecting the requirements, I have to do analysis on that. It means maybe the client may not know there are some repetitions. He is asking for 10 requirements, but that 10 requirements may not be required. Let us say 8 requirements is enough to address the 10 requirements. It means there is some repetition or redundancy that can be removed. So that is requirement analysis that we have to do. After that, you should go for design. After that, so here designing means architect will come. Like architect means he has to make boxes like, what exactly we have to do. It is like a, making a map. Like he has to map everything, what are the requirements and what we should do, and next who will come, and next up till the end actually he will design. Till the product end, he will design. But after designing, we have to write a code or coding, or we have to implement. This task will come. After coding or implement, who will come? Now the testing will come. Whether it is running properly, whether the tool or code is running properly, and what are the bugs are there. That bugs again, how to report, that is different thing. How to report that is what we call defects, management system like. So after testing, then release. We finally release the product, and maintenance also we will take care. So these are the phases where in SDLC. So here, coming to requirements, I told you already there are BRS, FRS, two concepts will come like. Here itself I tell you, BRS means will come under first stage, first phase like. What is BRS means? Business requirement specifications. It means the business actually we do not know in the beginning, because business people will know the process. I mean, what are the requirements and what are the things and how they are related with customers and what are the parameters and all they know. We just collect the requirements. So that is important. That is called business requirement specifications. That while we are taking, we should be cautious at this stage only. Otherwise, in the first phase, if it is gone wrong, that wrong will be shown and reflected, replicated in all other steps, like second step, third step, fourth step, in all steps, because it is time consuming, and it is very damage to the both. It is damage to the business people and damage to the tester, software development people also. So BRS is important. Then functional requirement specifications. In requirement analysis, we have to think like functional requirement specifications. It means, see, when you say functional, like, it means how we need to operate on the requirements that is collected at business level. It means you have to write some functions like. It means you should have exact logic how we need to operate on the collections collected from the business. That is called BRS. So these are very important in this case. After that, design, after that coding or implement, after the testing, and then only release and maintenance will come like that. Even in the before releasing, in between 5 and 6, the defects also will be there. Like, you have to find the defects and you have to report the defects. That reports, the defects should be removed. That is what we call bugs. That should be removed. In between, it will come like that. So some models are there for SDLC. So that models we will see now. SDLC models. There are different models like I can run waterfall. Number 2, iterative or iterative. Number 3, prototype. The name itself, it looks like maybe different and many, but they are very, very simple. V model. Agile model. See, finally, these are models like, when the requirement comes, how to model, right? We have to model in the what you call FRS, functional requirement specifications. After that, you have to model all the requirements, collected from the business. In order to model, there are different models are available, but generally, we prefer as of now, as I mentioned at the last, agile model. Now the industry market people are using more and more, as it is easy and interactive. Before, for small applications, we may go for waterfall model like that. In all models, again, what we do means, what are the pages I have mentioned in the beginning, in the last slide: requirement collection, requirement analysis, designing, coding, testing, all we do. Model means it is not like something only one part, like all phases will be there in this model. It means before we mentioned, right, one, I think almost 6 pages. That 6 pages will be there in each model. It means work is same, or what we have explained in the pages, each page, that is the work we do. But how we do is the important here. Let us say for small things like, for small applications, it means, small business, like for small business applications, the applications are requirements are, the requirements are very clear. Let us say clear requirements are there. In that case, I may go for waterfall model. Iterative can be called as like incremental. It means, see, every time it is like iterative means, see, it is like cycling. When cycling will come, when repetition will come, when there are some increments. Increments means when there are some changes after giving requirements also. It means requirements are not clear in this case. It means business requirements, BRS, business requirement specifications are not clear. In that case, we go for iterative. Prototype is another thing, like, prototype means something like block diagram. Block diagram we have to give to the business person. Once the business person come with requirements, I have to make a prototype, and first what I do is my prototype I will submit to that person. If the person accepts that, then I will go for, I will continue working on that SDLC cycle. Like V model also will be there. Like this V model is also actually mostly the people use. After that, agile model, it is like verification. V means verification and validation. Verification means generally we test every time, right? We verify and we decide whether it is good or bad. Validation means it is like testing. Okay, validation is like testing. Verification is just like finding bugs. Like both are looking like almost similar, but we think like we call for verification and validation. Generally the verification, this validation are testing. We go for actually feedback. It means when something is wrong, like we given feedback to the developers. That's why we called it as dynamic. Validation, generally called testing, is a dynamic process. It means every time it will vary, but this is the most proven one actually. V model is most proven one. It means mostly we use this, but agile is very accurate. But I told you, as it is cost oriented and all, we see agile model also most in the market, the people are using more and more. So now, what are the testing methodologies? There are some testing methodologies are there. With this testing methodologies, we can wrap up for today's session. So testing methodologies are generally two types. Like one is exhaustive, another one is optimal. See, very actually, we can use like little, like, commonly what we think, that thinking if we use, that is enough actually to understand this terminology. Exhaustive means, see, we all time actually from the beginning to ending, we are all, I told you already, BRS, FRS, these are the two terms. Every time it will repeatedly we work on that only. The questions also, even in interviews, such questions only they will ask, like what is BRS, what is FRS, and what are the exhaustive methodologies, what is optimal methodologies. Even the basic meaning, if you know, you can answer it. See, for suppose a business that BRS comes like infinite number of requirements. It means almost like exhaustive. Infinite anyhow, it's not possible. Generally, we don't need to talk. But let us say more like 10,000 requirements. Do you think that 10,000 requirements is sufficient to run to develop our SDLC, or to make a software development life cycle, or to make a product? Generally not, because if you take more and more, automatically requirements will be there. Like it means if the number of requirements are, if you take all the requirements, That is not possible. That is generally impossible. You cannot take all the requirements. That type of methodology is called, exhaustive type methodology. Generally, we don't prefer this. Why? Because requirements are many, like, because no one can take all possible cases. All possible cases, no one will take, like, because we do not know. We think that there are some possible cases. The possible cases are generally infinite to make a system 100%. So that is not possible. So if you take generally almost all the possible cases, generally it is impossible. But if you take it, then you can say that it is exhausted. Exhausted means I exhausted. It means I tired. Like that we call, right? When we tired, when we feel water, like something, like we can say that I am exhausted. I am exhausted this work with this work. It means the possible cases are many, that all possible cases I cannot take. So that is what you call exhaustive testing methodology. And optimal testing methodology. The requirements may be, let us say, 10,000. I optimized into 100. It means I told you all the redundancy I can remove, all the waste requirements I can, I can address that business person, so that he should convince first, right? So with that, I optimize. It means I make it more number of cases to little number of cases. It means here possible cases are little, number is less. Minimum number of possible cases, and mostly which are valid, and that is enough. That type of cases I will take. In that case, I can say that is like optimal testing methodology, we can say. So which one we go for generally now? Anyone go for exhaustive? No one will go for exhaustive. So we take most possible cases which are better. That optimal testing, again, two types are there. Like this also they may ask, like, BBT, black box testing, WBT, white box testing. Like, so what is black box testing is to validate without programming knowledge but client requirements. See, what is black box means? I told you even in the beginning, box, when you mention something that you do not know. Actually, behind the box, there is some, tool behind this box as a tool. If you think, there is something already developed behind the tool. It means behind what is happening that you do not know, but you know how to operate, and you will get what some input you will give and some output you will get. That is what actually black box like. It means the system, really the programming behind it you do not know. Behind the code or something, like, you do not know, but you know how to run it. That is like black box testing. It means we validate here, we validate without having programming knowledge. It means what is the system behind we do not know. Programming knowledge we don't have, but client requirements we know. We know what we know in this. We know client requirements. It means BRS we know. So that is what actually black box testing. So white box testing, who will do means generally tester will not do actually. This WBT will come under developers only. It means who are the coders, like who are doing code or who is going to develop source code, they will do this white box testing. So these two are optimal testing. In that optimal testing, there are the two types. One is black box testing and the second one is white box testing. So next we go for, actually in the next class, remaining manual testing can be done all together. All the concepts we can cover in the next class itself. So things will be there like system testing, and in that functional, non-functional, and then we go for another some sort of testing methodologies, and then Sdlc, like software testing life cycle, we will read. So with this, I'm going to wrap up for today's session. So if any doubts are there so far, people can ask me. Otherwise, we wrap up.
Yeah, AMMAJI, we are good for now.
Vijay, is it clear?
Okay, sir.
Is it?
Sir.
Tell me, Vijay.
One doubts అడగొచ్చు sir.
Yeah, see, I mean, you do one thing. Actually, time is up. Frankly, I have little time constraint. You can happily, you can post it in the group. I will answer. In the WhatsApp group, you please, post it. I will answer. And if you wherever the
Okay.
theory required, I will share the link also. Through that you can learn. Mostly I will answer all the possibility, all the possibility, but whatever the things, if you want extra knowledge, there I will share some
Yes.
links also. Okay.
Okay.
Okay, thank you. Thank you.
Thank
Yeah.